In 20, Part B, we're using a midpoint Riemann sum to estimate the area of the same function on the interval from -3 to 3 using 3 subintervals. So we're still dealing with the same 3 subintervals from -3 to -1, -1 to 1, and 1 to 3. But here, we're determining the height of the rectangles from the midpoint. So if we look at the first interval from -3 to -1, the midpoint would be -2. That's halfway in between the two endpoints. So the height of our rectangle comes from x equals -2. So our first rectangle looks like this. This height of this rectangle can be determined by putting -2 into our equation. So if we put -2 in here, -2 squared is 4, plus 1 is 5. And we can kind of tell that from the graph here, that the height is 5, our base is still 2. So the area of this rectangle is 10. Then our next interval, we're going from -1 to 1. The midpoint between -1 and 1 is 0. So we get our height from 0, and this is our rectangle right here. Base is still 2, the height is 1. Right? If we put 0 in here, 0 squared plus 1 is 1. So the area of this rectangle is just 2. And then our last rectangle, from 1 to 3, the midpoint is 2. So we're going to put 2 into this function, and we get 5 out again. That's going to be the height of our rectangle. So again, we have a height of 5, base of 2, which gives us an area of 10. So if we add these 3 areas up, we get an area of 22.